everyone. Welcome to the applied mechanics, the analysis of trusses. Here we can see a simply supported truss for a bridge, and this is a cantilever truss for a cord set. So there are two types of trusses: simply supported and cantilever truss. Then if we look at the trusses, there are fundamental assumptions in a plane truss. The plane in the sense the members and the loading in the same plane. The first is that all the slender members of truss are straight. We assume the members are straight here. Of course, here in this truss, this member is not straight. Little curvature is there, but we can start with the assumption of straight. Then the slender members are connected by the frictionless pin. That means this is a joint where we can see the pins. Then the external forces are applied at the pin only. That means the loads are applied through this. The loads are applied through the pin only. That means the loads are applied through these joints downwards or whatever. So at the joints only. Then all truss members and forces are in the same planes. Forces and members on the same plane. That is how we say plane truss. So now there is a simple sign rule for these members. While analyzing, we need to understand that whenever in a truss member, if there is arrow which is resisting is away from the joint, the arrow away from the joint we consider to be a tension member. Here arrow away from joint, arrow away from joint, arrow away from joint, either inside or outside, doesn't matter. So when the arrow is away from the joint, we consider to be, that member is considered to be tension. When the arrow towards the joint, either from outside towards the joint or from inside towards the joint, that member is considered to be compression. When arrow is away from the joint, the member to be considered as tension. Now, so what is the analysis? So the trusses, we need to analyze them. And what is analysis mean by that? Analysis means we can find out the loads, calculation of loads on the joint. Then we can find out joint displacements on the truss. We can also find the member forces. So this analysis can be done by two ways. One is a method of joints, second is method of sections. Then after the analysis is carried out, the trusses required to be designed. So design means we need to find a suitable section for the forces which we've worked out here, and find the strength criteria. That means what is the strength of that member. Then we find out whether these members are passing a serviceability criteria or not. We need to check. So let us look at an example of a method of joints. How to analyze a method of joints? A summary, a concept. So I am going to take a simply supported truss to understand the method of joints. So a procedure goes as follows. First, take entire truss is equilibrium. That means we remove these boundaries and apply a reaction force onto the boundaries. So this is particularly, I am talking about simply supported trusses. If the structure is, truss is cantilever truss, we don't follow this first step. We directly go to step 2. Right? So I removed the boundary. So this simply, it means what? I am going to draw free body diagram of the truss as a whole, and I will try to find out the reaction RAX, RAY and RBY. How do you find out that? So we apply the summation of Fx equal to 0, then summation of Fy equal to 0, and summation of M at any point here at A equal to 0. Why do you apply 3 equilibrium equations? Because these forces are non-concurrent. See, this force is coming here, this force is going this side, this joint force here. So they are non-concurrent. So non-concurrent coplanar forces will have 3 equilibrium equations. So now, once this is done by 3 equations, equilibrium equations, and I have 3 unknowns, RAX, RAY and RBY, I can find out them. Once this is done, I will go to individual joint in the step 2. So you have to choose a joint such a way that not more than 2 members are unknown. That means out of this truss, this once is done, RAY is known, RX is known. So I have to choose a joint from A, B, C, D, E, F, G, that which is joining with only 2 members. So which is possible only either joint A or joint B. Once I choose the joint, let us say this joint A, so RAX already found out, RAY already found out. So now I have left with only 2 members. So applying, these are concurrent forces. So reaction and member forces are both concurrent. I can apply 2 equilibrium equations, summation Fx equal to 0, summation Fy equal to 0, and I can find out the Fay because I know the angle theta. So I can find and tan theta is this opposite by the base side. So tan theta, then theta equal to tan inverse of that gives me the angle. Then once I finish this A and B, now I go to next joint, let us say joint C. Then once I found out C, so I cannot go to F because of course we can go here in this case because AF is known and FC is known, so only 2 members unknown. So I can go to here. Once this is finished, I can go to G because I know this, so these 2 are unknown. So likewise, I can go on moving on to all joints. So first of all, we assume all the members forces to be tension as far as possible. It's not hard and fast rule that always assume tension. If you know very well that member is compression, nothing wrong assuming the member to be compression. Proceed with the analysis. So then the step 3, complete all joints equilibrium and find the member forces. Then if you get a positive result by analyzing, that means your assumption of tension is true. So immediately write the member force as in the bracket T if your result is positive by assuming the tension. And suppose your result is negative, that means your member is compressive. Right? So this is a method of joint. So let us take a problem where we can calculate the member forces for the truss shown in figure. So this is basically a cantilever truss because this is a hinge joint, this is a hinge joint, and this is also a hinge joint which has the 2 reaction here, 2 reaction here, right? So I cannot find out this 4 reaction with 3 equilibrium equations. So therefore, I should not start finding this reaction forces. So for the cantilever trusses, start with this end joint D. So that's what I said here. Support A and B put together has 4 unknowns, 4 reactions, cannot be solved using 3 equilibrium equations. So that is why I start with the joint D. So this is joint D. So now I need to get this angle theta, because I know if this is a theta, opposite is 2 and base is your 4, so tan theta will be 2 by 4, and theta is tan inverse of 2 by 4, it's 1 by 2, it gives you 26.6 degrees. So I understand the angle theta equal to 26.6 degrees. Now since 600 Newton force is horizontal, FD is vertical, only FDC is inclined. If this force is aligned to the horizontal and vertical, I will be happy. So we can just align this FD force something like this. One this here and one this side. So when this FD force towards the angle, so this will have, so I can write this here. So FDC cos theta, and this FDC goes away from angle horizontally, it will be FDC sin theta. So applying summation fx equal 0 to this condition, I have only this and this horizontally, summation fx equal 0. That means 600 is the right hand side direction, positive, FDC sin theta positive, total equal to 0. That means sin theta I can understand. Okay, the sin theta means this opposite by hypotenuse. So I know sin theta value, right? Sin theta, so this value will be under root of 4 plus 4 square, whatever value comes there. So that will be my hypotenuse. So the 2 by under root of 16 plus 420 will give me sin theta value, known value. So I know 600. So directly FDC can be found out as minus 1340 Newton. So since I get minus, my assumption was arrow away from joint, which is positive away from joint means tension, but I got minus, that means it is compression. So simply I write immediately as a compression. This is very important to note down. Then once I finished with the summation fx horizontal equilibrium, I will also go to the vertical equilibrium. So what are the vertical direction forces are there? FDE and FDC cos theta, and both are same direction. I simply write down summation Fy equal to 0, and since they are downward, so I assume that positive right hand side is plus x and vertical upward is a plus. So this vertical downward minus FD, FDC cos theta also downward, so minus. Now I already know FDC is minus 1340, so I will directly substitute minus 1340. I will not change the value of, sign here. So by substituting FDC is 1340 here, just replace this with a minus 1340. So minus into minus plus, right? So the FDE becomes 1340 into cos theta. That is your 1198 Newton. Since I got positive, that means it is tension. So my assumed direction was right. Okay, so that's how I can write as a tension. So I finish the analysis of this. I have to move to next joint. That means this and this. So I go to joint C. So now I have to go to joint C. So what we do is simply make a line around the joint and cut off from the joint, and you will see the joint C like this. So this is joint C. this member horizontal, this is inclined, and both will have a same inclination. And whatever angle is, if I write a vertical line here, whatever angle this, it must be this, right? So now in this, all three forces are concurrent forces, and FCE is horizontal, nothing to worry. Only minus 1340 and FBC are inclined. They should be aligned. Okay, so this minus 1340 cos theta will be a vertical, and this direction minus 1340 sin theta will be the horizontal. So then I can very well remove this. Similarly, FCB. So if I can take this side, FCB cos theta, because towards angle, and this side will be FCB sin theta, then I can remove this. So I have now simply use summation fx equal to 0, and since the angle 26.6 degrees already we know, so this angle is nothing but this angle from the geometry. Okay, so this angle is nothing but this angle. So because I have got forces in horizontal direction, vertical direction, summation Fy equal to 0, that means minus 1340 upward, FCB downward. So simply FCD cos theta, FCD cos theta, this is nothing but FCD, right? So this 1340 what I wrote is FCD, which is upward, which has already value of negative, and FCB cos theta downward minus. So substituting the FCD, which is minus 1340, FCB can be found out. So that is nothing but my again minus 1340. That means it is compression. It is compression. Okay. So now taking next equilibrium condition, which is summation Fx, right? So Fx equal 0, we have positive FCB sin theta. Then I also have FCE, which is backside, which is minus FCE, plus inclined component of this FCD. So FCD sin theta away from angle. So I know FCB, I know FCD, which is from the previously 1340 minus 1340. Substituting this 13 minus 1340 sin theta cos sin theta known to me, FCB already found out. So I get FCE, which is 0. Right. So I got a 0. So the compression tension doesn't matter. No force is there. So now once I know, once I found out, this is done, this is done, this is also done, this is done. So I can go to joint E. I can find out these two forces. So I know this vertical ED tension, which is 1198, 900, because what I have to do now, this joint I have to cut it here. I am cutting a joint. So joint has a force, joint has member vertical, member horizontal, member inclined, member vertical. So I have to cut at the rounds. So this force I don't know, this force I don't know, but I know this force here member, but anyway 0. FEC anyway 0, so I don't have to put a member here. Anyway, this is 0. No meaning of mentioning the member. So these two are vertical, this is horizontal, nothing to worry. Only this one force we need to align to horizontal and vertical. So if I remove this, I can get this direction FEB cos alpha, and this direction FEB sin alpha, and that alpha angle can be found out as 26.6 degrees. Then, so now applying summation fx equal to 0, that 900 plus fe sin alpha, feb sin alpha. So feb sin alpha, sin alpha I know because alpha is known to me. So feb can be found out as minus 1273. Since negative, I can say the compression. So I let compression. Then summation fy, I have 1198. I have fea, I have fceb cos alpha. So downward is negative, upward is positive. Then I know FEB here minus 1173. Substitute minus 1173, 1273, minus and minus plus. So FEA can be found out directly, which is equal to 2098 Newton. Since it is positive, I'll assume to be, accept it as a tension. So I'll write as a tension. So after getting all the values, simply put it in the tabular form, where writing a serial number is member numbers and member names of that and force values in this column, and write the nature, either tension or compression, and that completes the truss analysis. Thank you.